Hello everybody, I have come with some more probability problems with permutation and counting principle. So let me begin with preliminaries on permutation and counting. So permutation basically refers to the number of possible arrangements of, ob- of the objects of a group. So see, for example, consider this set A and B. So the elements are A and B. These elements can be arranged in two ways. One is AB and another is BA. So basically in permutation the order matters. AB and BA are not same, unlike combination where AB and BA is taken as the same thing only. So in permutations, along with arrangements, the order of the arrangement also matters. So similarly, the total number of possible arrangement for A, B and C, if we take two at a time, are AB, AC, BC, CA, BA and CB. So that is equal to 6. These possible arrangements can be obtained either by using multiplication principle of counting or by using the formula for permutation. So what is counting? Counting means if a task can be done is in P ways and for each way of doing the task there are Q ways of doing another task, then both these tasks can be done together in P into Q ways. This is the basic principle of counting. Therefore, the possible arrangements are obtained by taking the products of the number of ways each selection can be made. Thus, in the above example, you see, first selection can be made in three ways because there are three possible values for the first selection. And since one selection has been already made, so now we are left with two more options for the second selection, which can be made in two ways. So the total number of possible arrangement is 3 into 2 is equal to 6. Similarly, number of 3 digits number that can be formed from the digit 1, 2, 3, 4 and 5 is, see there are 5 numbers, okay, 5 digits, and from 5 digit you are to select 3 digit number. So how many 3 digit numbers are possible? Let us see. A 3 digit number has unit place, 10th place and 100th place. So 100 place, let us begin from this side. So 100 place can be filled in 5 ways, means there are 5 options for the 100th place. For the 10th place, because one option goes in the 100th place, so there are 4 more options left for the 10th place. So 10th place can be filled in 4 ways, and after putting this two number, the last place has 3 options, so it can be filled in 3 ways. So we take the product of all these 3 and the total number of numbers is 60. This is how principle of counting applies. Now what is permutation? Using permutation, the total number of possible arrangement for n objects taken are at a time. Okay, so this n should always be greater than r, greater than or equal to r. And it is given by NPR. NPR is given by n factorial by n minus r factorial. So in the earlier case, the number of possible arrangement for the letters of this word A, B and C taken 2 at a time is C. N is here 3 and R is here 2. So it is equal to 3p2. That is 3 factorial by 3 minus 2 factorial, that is equal to 6. Similarly, if we take these letters A, B and C all at a time, then the total number of possible arrangement will be 3p3, which is equal to 3 factorial. And the possible arrangements are, all the possible arrangements are listed here: ABC, ACB, BSc, BCA, CAB and CBA. So in general, if there are n objects which is to be arranged taking all at a time, then the total number of possible arrangement of n object is given by n factorial. Now permutation with repetition. Here the letters are non-repeating. A is occurring once, B is occurring once, C is occurring once. Suppose the letters or the objects are repeated, then we divide the total number of arrangements by the factorial of the number of repetitions. So the number of arrangement of the letter of the word lava is, here there are 4 letters, so it will be 4 factorial. But since A is repeated twice, so we have to divide this by 2 factorial. So the total number of arrangement is equal to 12. Similarly, the total number of arrangement of the letter of the word paper is 6 factorial, because there are 6 letters, and since P is repeated twice, so we divide by 3 factorial, and since E is repeated twice, so we divide by 2 factorial. So total is 60. Now let us see another example. 25 books are placed in a shelf. Find the probability that a particular pair of books shall be always together and never together. Now, since 25 books are to be arranged, so the total number of exhaustive cases is 25 factorial, because 25 objects can be arranged in 25 factorial ways, as we have seen earlier. Now we want a particular pair of books to be always together. So what we can do, we can combine that particular pair of book and count it as one, just like the earlier sum. So the total number of books will be 24. 23 plus 1, 24, which can be arranged in 24 factorial ways. And also the pair of books can be arranged among themselves in 2 factorial ways. So the total number of arrangements will be 24 factorial into 2 factorial. Therefore, the required probability will be 24 factorial into 2 factorial by 25 factorial, which is reduced to 2 by 25. Now let us see the second one. A particular book, pair of book is never together. Now this event, this never together event, is a complementary event to event A. One is always together, another is never together. So these are complementary event. So the probability of complementary event A complement can be found by simply subtracting probability of A complement equal to 1 minus probability of A, which is equal to 1 minus 2 by 25, that is equal to 23 by 25. So hope you have understood. Thank you.